a very warm welcome to you once again as you join us for another Paramics Workshop 2020. My name is Malcolm and this is the third session that we're doing this year as we bring the workshops to you online. And the reason for that, of course, is because of the coronavirus pandemic. It means we're unable to travel or to gather in groups as we would usually do. But what we are doing is bringing you the same content that we would do if we were gathering for a day's workshop. We're just bringing it online in smaller chunks. So we're releasing one of these videos every week at noon on a Wednesday. We're keeping them quite short so that you can fit them into your busy schedules. Now, the first two sessions we looked at an introduction to the workshops, the news of what we've been doing in the last year, and some of the features in Paramics Discovery 23. In this session, we're going to start to look at features that are coming in Paramics Discovery version 24 later in the summer. Now, there's a lot in this version, so I can't cover all the features today, but it'll be roughly about half of them that we'll look at together. So, without further ado, let's get into today's session. So the first feature I want to share with you today is the new ability to see the exact route that an individual vehicle will take as it travels through the network. Now, I've got a model in front of me that I'm going to use for this demonstration. Before we look at the route of the individual vehicle, we'll have a look at some of the routes of the aggregate vehicles. And we can do that using the route viewer on the Visualize tab. So I've opened up the route viewer and I'm just selecting an origin and destination pair and looking at the routes that vehicles will take. Now, with a perturbation of 0, I'm getting an all or nothing route there. If I increase that perturbation value, let's say I put it up to 5, I can then start to see a little bit of variation around the routes that are chosen from that origin to destination, because the costs of those routes aren't that different. And I can select the different options in the route viewer. So that's looking at all of the vehicles, if you like, from that origin to that destination and the likely routes that they're going to take as they move through the simulation. But what the new feature is about is being able to select an individual vehicle and see exactly which route that individual vehicle is going to take. So to help me select an individual vehicle, I'm going to open up my vehicle marking and I'm going to type in the same origin and destination. So it's 68316 as my origin zone and 68311 as my destination zone. And that's now marking all the vehicles going from that origin to that destination in green. So I'm just slowing the simulation down there so I can catch one of these. So I want to find one of the green vehicles. There we go. So I know it's going it's from the origin to the destination of my choice. And now I want to see the route that that vehicle is going to take. And the button to do that is at the toolbar at the top, turn vehicle paths on or off. So I click on that and you can immediately see this bright pink line showing very clearly the route that that individual vehicle is going to take from its origin to its destination. So this feature is giving us a great ability to interrogate on a much more detailed level the behavior of individual vehicles. I'll select another one and I can see that that's a slightly different route for that vehicle. Okay, now this can be very useful for developing your model, especially maybe when you're adding traffic on for the first time and you want to see where the vehicles are going to and from, or perhaps when you're at a real calibration stage of the network and you can interrogate that routing behavior in a level of detail that you couldn't do previously. Okay, so that's the first new feature that I want to show you. It's quite straightforward to use and to understand. It's just a toolbar button at the top of the Visualize tab and you just toggle it on or off and select the vehicle, and you can see the route that it's taking from its origin to its destination. Okay, now the next feature that I'm going to show you is quite similar to the first one in the sense that it's about interrogating information about an individual vehicle as it moves through the network. But rather than looking at routes, this time we're going to be looking at lane choice and hazard awareness. Now, to help me with this, I'm opening up the vehicle marking panel from the Visualize menu. And I'm going to mark vehicles going to a specific zone. So I'm just going to type that in here, 61506, so that I can see the lane use and the hazard awareness of those vehicles as they go through the network. Okay, so I'm looking at the green vehicles coming from the south approach. I'm selecting one of those, and the first thing I'm going to do is just look at the information about that vehicle. So I can do that by clicking on that button in the toolbar, which is turning vehicle information on. And that gives me lots of information about that vehicle. And some of that information includes the lane range, and the next lane of the vehicle. Now, that's really useful information, but up to now you would have had to click on that button to really see that. And essentially what this next feature does is it allows you to see that displayed on the network. So it's much simpler to understand. And you can do that by toggling on this button here. Now, you can see the graphical display. Let me turn off the information to make it more clear. Now, we know that the lane the vehicle's in is lane 2, that's obvious. The lane range is 1 to 2, and you can see that by the box. And the next lane then is 3, and you can see that because the line drawn forward from the vehicle is going into lane 3. And if we look back at the information, we can see that confirmed. The lane is 2, the lane range is 1 to 2, and the next lane is 3 for that vehicle. So it's really a way of displaying that information on the network, much easier to see and to understand. And if I select other vehicles around it, you can see their information displayed as well. Okay, so that's looking at a vehicle which is static and the information about that vehicle, but we can also do that for a vehicle as it moves through the network. So let's have a look at that next. I'm going to select this vehicle, and we can see that it's in lane 2. We know the lane range is 2 because we can see that's where the box is drawn, and it's going into a next lane of 3. Now, if I follow that vehicle and make sure the angle's fixed, I'm going to just slow the simulation down so it doesn't run away from me too quickly and start the simulation, and I can see that vehicle now moving through the network. And you can see the information updating in real time about the lane and the next lane as it moves through. Now, that information has a limit to how far downstream it can be displayed. So it's really just the next link ahead that it's looking, and it's able to provide that information. If we want to understand more about the vehicle's behavior further downstream, then we need to look at the next feature, which is toggling on the hazard awareness. So I've toggled that on, and what we can see here is several new graphics displayed going much further downstream for that vehicle. Now, hazards can be all kinds of things, and we're actually going to cover that in a later workshop session in more detail. But this is essentially telling us the lanes that the vehicle can be in further downstream as it travels through the network in response to the hazards that it's observing. So we can see, for example, that this green vehicle that we've selected can use lanes 1 or lane 2 as it travels through the network along this section, and as that vehicle moves, again, the display is updated in real time. Now, I can see as it is going to get to the next junction that the vehicle is going to be turning right, and you might wonder, why is it able to use lane 1 and lane 2 if it's making that right turn? Wouldn't that just be lane 2? And if we zoom in on the junction, we can see the reason is because there's a right turn from lane 1 and from lane 2. So the hazard, which will have been produced by that junction, is telling the vehicle it can be in either lane 1 or lane 2, and we know that that vehicle is choosing lane 2. So the vehicle moves round the corner, and now we can see that the feedback from the hazard coming to that vehicle is that it could be in lanes 1 to 3 on these particular links. But we can also see, as we look a little bit further downstream, that the information from the hazard is that the vehicle needs to be in lane 3. And you can see that there. And that's because it's turning right at that junction, and to turn right it needs to be in lane 3. So that information is being fed back to the vehicle, which we can see is in lane 3 and is choosing its next lane to be in 3. And so when we run the simulation on, we can observe how that vehicle behaves. And it's staying in lane 3 and then making the right turn as we would expect. Okay, so this feature is about selecting an individual vehicle and really seeing a lot more information about how that vehicle is going to behave, and essentially the information that that vehicle is receiving from the network in terms of its lane range, the next lane it wants to be in, and also its hazard awareness. So similar to the first feature around routes, this is very, very useful when you add traffic onto your network and you're trying to get the vehicle behavior to work effectively, especially around the time of calibrating a model. Okay, so the third feature I want to show you today is really in the same family of features as the first two, in the sense that it's about selecting an individual vehicle and being able to see in more detail how that vehicle is behaving and why it's behaving in that way. Now this one is really going to focus in on the gap acceptance of a vehicle, how one vehicle gives way to another. And to demonstrate this, we're going to use the crossroads in front of me. Okay, so I'm in 3 dimensions now in the simulation. I'm just going to look a little bit more detail at this junction, and particularly looking at the priorities. Now we've got major movements on the east and the west, and so the straight ahead movements and the left turns from the east and west are major. From the north and south then is where we're getting give way behavior. Now we've got medium priorities for the left turns from the north and south, and we've got minor priorities for the straight ahead and right movements. So a range of different priorities at this junction. Let's start the simulation and just look at how some of the vehicles are behaving and how we can use this new feature. So I'm going to toggle on the button at the top. Again, it's on the toolbar at the top of the Visualize tab. This one is looking at a vehicle's gap acceptance. So when that is toggled on and I select a vehicle, I can see the links that that vehicle is looking to for its gap acceptance decision, and any vehicle that it is picking up on those links. So we can see the 3 links on the other approaches that that vehicle is seeing, as well as the blue car which it has identified that it needs to give way to. And we can clearly see that this green vehicle needs to give way to several other vehicles which are coming in a stream of major movement from the west. And as each one of those goes through, it gets picked up, and we're also seeing vehicles picked up coming from the east of the junction as well. Okay, now by default the vehicles will be looking at one link adjacent to the approach that it's taking, but there's circumstances where a vehicle may need to look beyond one link, and this is such a case. If we look at the white vehicle moving through, we might expect it to be giving way to the blue and gold vehicle, and the same goes for the green vehicle which is about to come through the junction as well. Now we can see that green vehicle is not giving way. Now fair enough, it didn't give way to the blue one because it was turning left, but a very close call with the gold vehicle which was moving through. And the reason for that is that there's a short link on the west side of this junction, and you can see that short link just in here. Now, by default, that green vehicle is only looking onto that short link for its gap acceptance, whereas it really should be looking on the previous link as well, and would do in reality. And there is a way to address this in Paramics Discovery, and some of you will be familiar with this, no doubt, and that is to apply something called a look-through onto that link. So I'm going to select that link in the Edit Network tab, just go to the Properties quickly and toggle on Look Through. And then if I go back into my Visualize tab and look at my Network Review section and click Look Through and just refresh that, I can see that blue dot is showing me that that parameter has been applied onto that link. Now what that means is that when a vehicle is now approaching from the south, it's going to be able to look through that link and it can see the vehicle on the previous link, and we can see that in the example here of the vehicle that I've got pre-selected. And so the vehicle from the south is giving way to the vehicle which was coming from the east, and only once that is moved through is it then able to move through the junction itself. So hopefully that gives you a good sense of what this feature can do by selecting an individual vehicle as it's approaching junctions. As you can see with the blue vehicle in front of you, it's showing us the links that that vehicle is looking on for its give way decision, and it's then showing us which vehicles it will be giving way to, and you can see them highlighted with the dot as they pass through. Okay, now the next feature that I want to show you in this workshop session today is quite different from those first three, and it falls into a category of new features called incidents. Specifically, I want to show you today how you can model a vehicle breakdown. Now I'm going to be using this quite large model in front of me today with some route choice in it to show you how we can model a vehicle breakdown and the impact that has on the rest of the network. So I'm selecting a link on this network on one of the main routes through the town centre, and I can go to a new dialog in the Edit Network menu called Incidents. And when I've opened that, I can add a new incident. Now, I want to call this incident Vehicle Breakdown because what I'm modelling here is a vehicle breaking down for a certain length of time and then the impact that that has on the rest of the network. Now, I can add the link in where that vehicle breakdown is going to happen, and you can see it appear on that link. It will place itself on the midpoint of that link by default, but I can easily move that up and down by dragging or dropping, or I can change the distance in the dialog. We can set the number of lanes that the incident is going to occur across. Now in this case there is only one lane on this link heading to the northeast, so we can leave that as so. And then we can set an early start time and a late start time, so we can give a window in which this vehicle breakdown is going to happen. So we don't have to prescribe an exact time, but we can give this window, and then the software will choose randomly a time within that window for the vehicle to break down. In a similar kind of way, when it comes to the breakdown duration, we can set a minimum and a maximum time. And again, Paramics will randomly choose a value in between those two boundaries for the vehicle breakdown time. So you don't have to be too prescriptive about this vehicle breakdown, and you can let the software make some of the decisions for you, bring in a little bit of variation to that. Now, we can also choose the number of occurrences. We'll just leave it at 1 for now, and the vehicle type, and we'll set that to car. So that is the incident set up as a vehicle breakdown. Now if I go to the Visualize tab and refresh that, my incident will appear on the screen. I've got some traffic onto the network now, and you can see there is a queue along that route where the vehicle breakdown is going to occur. and we're just before the time that the breakdown will occur. But before I run the simulation on and see the operation of the network with the vehicle breakdown, I want to have a look at the routes that vehicles are using through this part of the network. And to do that, I'm going to go to my Visualize menu and the route viewer, and I want to select a route from the major junction before the vehicle breakdown to a major zone on the other side of the network, so over here. And what this is showing me is that the main route through the network here is along that road where the vehicle breakdown is going to occur. So what I'm wanting to look at is what is going to happen when this vehicle breakdown occurs to the route choice of vehicles. So I've started the simulation running, and we can see now that vehicle breakdown happening. It's happened at the time that I would expect, and also you can see the duration is between 8 and 10 minutes. Now, what's effectively happening in the simulation is it's just picking a vehicle based on the criteria that I've set, so it's a car, and it's choosing that for the incident, and it's stopping that vehicle for the length of time. We can see that the incident clock is counting down as that work moves through the breakdown to when it's going to end. Now, the route that's being chosen is changing. You can see that just changed to the more inland route there, and that's because the congestion has built up because of that vehicle breakdown, increasing the cost of that route sufficiently so that now the preferred route, or the lower cost route, is to go inland and choose an alternative road. Now let's keep the simulation going until the breakdown is complete, and we can see now the traffic is released and the congestion dissipates once more. Now I've run the simulation on a little bit further there just to save some time, and what I'm expecting to see now is as that congestion has dissipated and it's no longer adding that delay to the cost of the route, that route will switch back to the main seafront. And we can see a little bit further through the simulation that that has occurred. So this can be a really useful feature for modeling incidents in Paramics Discovery. And this is one type of incident of a number that we're going to be demonstrating in future workshops. This one is about a vehicle breakdown, where you can define when the vehicle is going to break down, for how long it's going to break down, and you can see how the rest of the traffic will respond to that incident and what the behavior is likely to be on your network. So the final demonstration that I want to do is another one using the incidents feature, which has been introduced to Paramics Discovery 24. Now in the previous example we looked at a vehicle breakdown and specifically the rerouting that resulted as the congestion formed from that breakdown. In this example we're going to look at an accident on a motorway or a highway. So I've got a motorway model in front of me, and we can see that we've got 4 lanes in each direction, so quite a large motorway. Now I'm going to select a link on one of the sides of this motorway, and then through the Edit Network menu I'm going to open up my incidents dialog again. And again I'm going to add a new incident, and this one I'm going to call motorway accident. Okay, and I need to type in the link that this is occurring on, so I'll do that and we'll be able to see the accident appear on the link. And just like the previous example, I can move that motorway accident up and down the link as I see fit. Now the important thing about this demonstration is that we can set the number of lanes. So previously we were just looking at a 1-lane link, and so the breakdown was going to block all lanes. In this example we can set the number of lanes, so we could say that the accident affects all of them, or maybe just one of them. Let's set it to 2 lanes. So 2 lanes are going to be blocked as a result of this accident, which means that The other 2 lanes are going to remain open to traffic. Again, as in the previous example, we can set an earliest start time and a latest start time. And we will also be able to set a minimum duration and maximum duration. So this is going to occur between 6:30 and 6:32, and we'll just say it's going to be exactly 10 minutes for this accident. We'll leave the number of occurrences as 1 because we'd only expect 1 accident in this kind of case. And the vehicle type, we can just leave that as all, and it will randomly choose a vehicle type. So I'll close that, save the model, and go to my Visualize tab and refresh, and I can see the motorway accident appearing. And start the simulation, and it's running very quickly because it's quite a small model, and we can see immediately the motorway accident has occurred. Now what it's effectively done, because we've set it to 2 lanes, is it stopped 2 vehicles at the same time in lane 1 and lane 2. And again we can see that countdown clock, which is telling us how long is left for the accident to clear. Now in a real accident example this might be much longer than 10 minutes, but just for demonstration purposes I've kept it quite short. You can see there's some congestion forming in lanes 1 and lane 2, but we're also seeing some traffic getting through in lanes 3 and lane 4. So we're not getting a complete block of traffic, we are getting some traffic through as a result of the accident or the lanes remaining open after this accident. And then when the timer finishes on the incident, the traffic will be free flowing once again. And you can see that the congestion has relieved itself. Now I'm going to do another example and set the accident to block all 4 lanes just so we can see what happens. So I've done that quickly in my incidents dialog and start the simulation again, and we're going to let this run through a little bit quicker so it happens, and you can see this time we've got 4 vehicles blocking all 4 lanes, and that means no traffic is getting through as a result of this accident, and all the congestion is forming in all 4 lanes behind where the accident is taking place. So this can be quite useful to test the impact of an accident affecting 1 lane or 2 lanes or 3, or in this case 4, and what impact that might have, for example, on journey times. And I've actually done a little test here where we can see in the Analyze tab I've got 3 data plots which I've set up. One has no incident, the second has 2 lanes blocked, and the third is 4 lanes blocked. And you can see the average journey times over a 30-minute period from 6:30 to 7, which encompasses the whole incident in this case. And you can see the difference in journey times that occur. So the yellow, the 133, is where there's no incident. The 194 is where you've got 2 lanes, and the higher number was 4 lanes blocked. Okay, so hopefully that is useful and interesting for you, just to give you a bit of insight into how to model an accident on a motorway or a highway network, and the impact that that can have on the surrounding traffic and on the journey times of the rest of the vehicles that are using that particular network. So that's it for our workshop session today, as we've looked at some of the new features coming to Paramics Discovery 24 later in the summer. And particularly we've looked at the ability now to interrogate individual vehicles, whether that's to do with their route choice, their lane choice and hazard awareness, or their gap acceptance. And we've also looked at incidents with a view to how we model vehicle breakdown and accidents on highways. Now there's lots more to show you about Paramics Discovery 24, but we're going to be doing that a little bit later in this series. Next week we're going to be starting the first of a few sessions on good practice, and looking specifically at hazards and lane use, and that's going to be led by one of our really experienced trainers, Graham Smith. So I hope you can join us next week for that session. Thank you once again for joining us today, and we'll see you soon.